I'm going to give an overview on the keyword extraction and also a brief introduction with the open source Python tools for the purpose of keyword extraction. So what is keyword extraction? It is actually the automatic process of extracting the most relevant and important words and phrases, like the keywords, key phrases from the text. So it has many use cases, such like the social media monitoring, brand monitoring, customer service support, feedback collections, BI, search engine optimizations, product analysis, knowledge management, and so on. So what's the values? Basically, it saves money, it saves time, and it can distill the big data to capture the most important information just in seconds, rather than hours or even days. Also, it enables you to obtain actionable insights, help you understand your data, your customer for a data-driven, AI-driven approach. For example, it can help you to understand answer the question like what percentage of the customer reviews are saying something related to the price, and so on. So keyword extraction has many advantages, such like it is easy to set up and use, and also it will automatically index your data and generate keyword tag clause. Of course, and it's scalable and use consistent criteria, and also enable the real-time analysis. So there are many methodologies for the keyword extraction, such like statistical, linguistic, graph-based, machine learning, or hybrid scheme. So also there are many open source Python libraries and packages available for keyword extraction. Here I just give a few minutes quick introduction to the concept of keyword extraction, and then we'll go to the notebook for some hands-on using all these open source tools. Here also I provide some reference for the tutorial and the resources about the keyword extraction and so on. Okay, no time to waste. Let's go to the notebook. So the first open source package we are going to look at is the rake-nltk. Rake is standard for the Rapid Automatic Keyword Extraction algorithm. So there I provide its GitHub repo and also the Python implementation. So rake is really simple to use. You just import the rake packages from the rake-nltk and starting to call it, initialize some rake instance, and then this is your the sample text you can just supply, and then call the extract keywords from text method and generate the ranked phrases. So you can see it very nicely to generate all the keywords I want. Also, you can show the ranking scores for each keywords generated as well, just like get ranked phrases with the scores command will do this kind of job. Okay, so let's move to the second one, which is the scaling with the tf-idf score method. So there is some excellent tutorial available, and also some repos and the notebook, and you can just take a look. So here we're just using the Stack Overflow dataset as the samples to actually try the scaling tf-idf method. Okay, so here you just load your Stack Overflow training samples, and here you can see we got about 20 key sample records, and it has the 19 attributes columns. Okay, so basically such kind of the Stack Overflow dataset contains 19 fields, including all these post, title, body, text, and other metadata. So what we are really interested in is just like the text field, which is the body and the title of each record. Okay, so that is going to be our source data to process and generate the keywords. So for this purpose, we just create a new field called the text that combines both body and the title field. So then we can have the all the text in the main field. Then we just define some pre-processing function to actually to clean up the text body, like the lowercase, and remove the text and all the special characters and digits and so on. Okay, you can see after we actually to do the text data pre-processing. So this is the original data. Okay, show a lot of the HTML, the marks and the codes, and then this is cleaning up the text data, which is much better. So after the data processing, we're going to create the tf-idf. So what is tf-idf? TF stands for the term frequency, and the idf stands for the inverse document frequency. Okay, so we're going to generate the term frequency using scikit-learn's count vectorizer to create the vocabulary and generate the word counts. So the result of this, the code chunk here, okay, just like to get the fox here, okay. So basically, the result of the last two lines of code here is actually the Sparse Matrix representation of the word counts, meaning each column represents a word that is also called the term or token in the vocabulary, and each row represents a document or record in our dataset, where the values are the word counts, that is term frequency, TF. Here, if you like, you can also define your list of the stop words you want to remove from the raw text, and by doing so, and you can also define these hypermeters. So basically, it means you just ignore those common words that appear in the more than 85% of all the documents. So that is a tunable hypermeters, normally in the range of 0.7 to 1. So this parameter will be ignored if the vocabulary hyperparameters is not long. Okay, so after you define the count vectorizer, and you actually use the fit transform method to actually to generate the sparse matrix representation of the word counts. Okay, done. After we do that, let's check the result. Here you can see the shape of the sparse matrix is 20 key and this. That's because we have the 20 key the documents in our dataset, and also the vocabulary size is the 124 key plus, because we have the all these unique words in our dataset. So optionally, in some data mining, such a text classification and clustering work, we may limit the size of the vocabulary. It's really easy to do so by setting the max feature equal to the any vocabulary size you want when initialize your count vectorizer. So here, we just show the examples. Okay, you can just specify how many vocabularies, by using the max features hyperparameter. Okay, here you can see now we generate for the 20 key records and the 10 key vocabulary as we specified. Okay, so here you can see also the word counts in a sparse matrix representation. Okay, yeah. Right. Okay, so we can take a look at all the words and tokens from our vocabulary generated by the count vectorizer. Okay, so you can also get the vocabulary by using the get feature names method. Okay, yeah. So cool. So in the next step, we are going to using scikit-learn's tf-idf transformer to compute the inverse document frequency, IDF. So in the code below, we are essentially taking the term frequency sparse matrix from the count vectorizer output to generate the IDF when you invoke the fit method. So an extremely important point to note here is that the IDF should be based on the large enough corpus and should be representative of the text you would be using to extract keywords. that is using the similar and relevant texts and the document in the same similar domain as training data. So to understand why the IDF should be based on the field like the big data, please read this page from Stanford Information Retrieval online book. Okay, so here we go. We actually to initialize the tf-idf transformer, and then we call the fit function to actually to learn from the word counts vector. So after we done that, you can see the IDF is actually can generate the the tf-idf transformer can generate all the IDF for the all the the words in the our vocabulary. So here it is important to know the IDF is global, so just one value for each word token in the whole vocabulary, regardless of how many records. So for example, say if you have like 100 records, and if one word token only appears in one record, its document frequency is 100th. Thus its IDF is 100. Yeah. So in this way, for another word token which appears in like 50 out of 100 records, its IDF will be 2. So the former word token has much higher IDF score than the latter one, because the fact that it only appears in 1 out of like 100 records contains much more information itself, and is very unique in the whole collection of the records. Okay. So in the next step, we actually compute the tf-idf score and extract the keywords. So once we have our IDF computed, and we are now ready to compute the tf-idf score and extract the top keywords. In this example, we'll extract the top keywords for the questions in the Stack Overflow test samples. This test sample dataset has 500 questions with a field identical to that of the training dataset here. Okay, so as we see before, and we'll start by reading our test file, extracting the necessary field, that is the title and the body, and get the text into the list. Okay, so this code chunk basically do this kind of function. In the following, I define the utility functions to sort and get the top n keywords key phrases for each document record according to their tf-idf score ranking. Here, n is the number of keywords you want to retrieve from document. You can define any number, okay, as you wish. So here, it is very critical to actually to explain the rationale for the tf-idf method for the keyword extraction. So basically, if a word is more unique globally among all the documents, and it appears more frequently in any given document, so its tf-idf score in that document is higher. Therefore, it should be regarded as like the top ranking keywords to be extracted. Okay. So this is the utility function we defined, and then here we also like to note like the keyword extraction from test date document and records. The next step is to compute the tf-idf value for any given document in our test date. Okay, by invoking this tf-idf transform function. So we're going to actually to using all these functions and the tf-idf the result, and to generate our tf-idf scores and the corresponding keywords for any document. Okay. So next we sort the word in the vector and in the descending order of the tf-idf values, and then iterate over it to actually extract the top items with the corresponding features. And in the example below, we are extracting the keywords from the first document in our test date. Okay. Here in the utility function here, okay, so you can see like the sort code is actually essentially sort the values in the vector while preserving the column index. Once you have the column index, it is really easy to look up the corresponding word values, as you would see in this another utility function I defined above. Okay. So This is the, like we use just using the first like the test samples to test it. So here, the title, bodies, and text, and the keyword we extracted with the score, tf-idf scores. Okay, so okay. So observations from the keywords above, Okay, so you can see the top keywords actually make sense. It talks about economics, Mavins, integrate, war, and the Tomcat, which are unique to this specific Stack Overflow question. Okay, so then all in one, I define the utility function to, just like a randomly freely select and test any document samples as follows. Okay, just like define just all this can use for functions to actually streamline my job. Okay, so here you can see after I done that, I just can just supply any index of the document and then let it generate the keywords. Okay, for this one, the tf-idf method give me the keywords like this, so it's good but not yet perfect. So the one issues with this tf-idf method so far is it can only give me like the single word as a keyword. So sometimes I probably also want some like the bigram and the trigram and some like key phrases. So for this purpose, let's enhance a bit the current tf-idf method by enabling n-gram support. Okay. So of course here the two options, you can either remove the frequent words and the stop words, or you can just keep it. So let's just like keep it for a moment. So in following, I just combine the count vectorizer and the n-gram in the Python, and it is simply to add the n-gram range parameter when you initialize the count vectorizer. And here we just enable like the unigram and the bigram. Of course, you can specify the any n-gram range you want. So then you actually to call the count vectorizer fit transform method to generate the word count sparse matrix. Okay, and then you can see here we got the 20 key records, and then we got like about 118 key plus the unique words in our vocabulary by enable both the unigram and the bigram. Okay, so after we done that, we can again we are actually to retrain we are actually retrain the tf-idf transformer, because the the term frequency matrix become different. Okay, so you just like fit using the fit method to actually retrain again. Okay, so now after we done that, okay, so we can just do some in-domain testing for the tf-idf method with the n-gram enabled. So okay, so this is like any test document index. For example, 120 is document we can test. It's talking about like a SQL import wizard error. So you can see the it's now very wisely pick up the most important information about this issue, such like the date convention, right? And also the SQL import column decimals are quite relevant. So it's good job of the tf-idf with the n-gram. Okay, we can test any like test samples. So for example, another samples we test it, and it's capable of pick up the most important information about the issue, like the war plugin, also the Eclipse, Maven, Tomcat project. Okay, are quite relevant. So let's actually to challenge our tf-idf method a bit by actually using some auto domain testing samples. So here I'm just like get some like a topic from the neuron science. Okay, so and then this is like a describe just like overview of the neuron science, the core concepts. Okay, so then again we call the tf-idf transform function, and to generate the tf-idf score for the this given test sample. and then we actually to sort out like what's the keywords from it. So from here you can see this is the neuroscience core concepts, and this the keywords is retrieved. So from result, the it says looks not so bad. The tf-idf method trained on the Stack Overflow domain data can still pick up some like the useful keywords in the neuroscience domain, such like the brain, the human, but not others like the neuroscience and so on. Right? So a summary of the scikit-learn with tf-idf for keyword extraction. The result is initial and is promising to some degree. The model is able to generalize for the new text out of the training domain, but in principle, you should ensure that the test samples to predict should fall into the same or similar domain as the training data to make the tf-idf method working validly and properly. So also the single keyword, the unigram is extracted, but not the key phrases as like the rake-nltk does by default. So I enable the n-gram, it can give like some key phrases like the human bar, but the key phrases such like the nervous system are still missing. That is simply because such a phrase does not exist in the training Stack Overflow data set at all. So that proves from another angle, so how heavily the tf-idf method accuracy depends on the relevance and the representativeness of the training text data to the target sample to predict. So here is the tentative conclusion. So the tf-idf is highly customizable and tunable, excellent for the in-domain prediction, but it requires quite like the large amount of data to be able to generalize well and requires some trial and error to fine-tuning. Okay. So the next open source Python tool and package we are going to look at is the Python keyword extraction PKE. So PKE is actually provide a standardized API for extracting the keywords and key phrases for a document. So the input can be either file or text string, very flexible. And the PKE uses the NLTK and the SPACE under the hood. So there's also the tutorials and the code documentations available here. So it provides some end-to-end key phrase extraction pipeline in which each component algorithm can be easily replaced and changed and modified or extended to develop new models. So the PKE also allows for the easy benchmarking of the state-of-art keywords extraction models and ship with the supervised models trained on some bigger dataset. So you can see like the many models are supported by the PKE, including like the unsupervised models such like statistical models or the graph models, or like a supervised model like the feature-based models and so on. Okay, and it's really simple to using the PKE. You just like type in like 5 lines code below, and you actually get the keywords extracted from the any document, okay, text document. So let's try it. You input the PKE, and then you here we're just using the unsupervised model and the topic rank, the algorithm. Okay, so you just initialize one such kind of extractor, and then load any document you want to generate the keywords, and then call all these kind of commands, and the extractor gets the top n best keywords predicted. So here you can see from this the samples, because like all these can nicely the keyword extracted. Okay. So also we test using our Stack Overflow test dataset. So here again is actually talking about this kind of like economics, the plugin issues, and you can see the small web project economics, Tomcat server possibilities or tutorials, and it is also quite nice and quite accurate. Okay. So the last but not least, the open source packages we are looking at for keyword extraction is called the flash text. So this model actually can be used to either replace keywords in the sentences or extract keywords from sentences. It's based on the flash text algorithm. So here I provided its reports and documentations and so on. So you just like import the keyword flash text, and then you actually to define the ending keywords, So this is actually the drawback for the flash text, And here, you just define all these keywords, and then this is your keyword list. By doing so, you can just like to let it to predict any keywords from any text. So here we can go like New York, Bay Area, and action point. And this is just their dummy samples. Here I'm going to go to something more like the real world samples. Here I actually, for some like business use cases, I add a lot of like the keywords to the flash text keywords definition list. So a lot of them. And then I just like test on any like test samples. So here is my text text, and I call the flash text, the extract keywords. Okay, and you can see for this test case, all these kind of actionable inside the big data, business decisions, customer review, and so on can be found. It's very accurate. Okay, so the flash text do have the pros and cons. So the advantage, it is highly flexible and can self-define a customized keyword list. But the drawback is actually it requires manual definition of the keywords list, and also the input only accepts the key strings, not the file. Okay. So here is some like the summary of my assessment for the different keyword extraction tools. So for the PKE, so it is regarded by me as like the best of the breed. So it's accurate, powerful with many algorithms support both file and or text string as like input, easy to use, generalized well with for zero shot prediction. For most use cases, that is very important. So whereas for the rake-nltk, so it's pretty accurate, automatic, and easy to use. However, its result is a bit verbose, like a lot of like very long phrases and so on. For flash text, it is a highly customizable, accurate, and optimized to specific domain vocabulary. But the disadvantage of it is need like the manual definition of the customized keywords lookup list, right? So also for the current tf-idf method, so it's highly tunable, excellent for the in-domain prediction. However, it requires big data to be able to generalize well and requires the manual work. That is, its quality depends on the training data quality. Also requires relevant and representative documents for training to be able to generate some good models for testing domain. Okay, so all in all, so the my recommendation is if you got a test text from which you would like to extract keywords, but have no idea where to start with, just try the PK first. Its zero shot prediction ability often can deliver good or even excellent results in the first place. Okay. Okay, this is our short introduction to the keyword extraction and the open source Python libraries. So do subscribe to the channel if you want to keep updated on the latest AI machine learning technologies, trends, and topics. Also, download a copy of this slide deck and also this step-by-step hands-on notebook for your own study and learning. Plus, we also have many more free data science ebooks and resources available. Okay, thank you very much. See you later.